A couple of weeks ago, we showed you PPL electric utility crews installing a smart grid device to a section of their power lines in an effort to improve service and help guard the utility against potential cyber attacks. We wanted to learn more about these cyber-based threats to our nation's infrastructure, as well as our emerging technologies. I went to Lehigh University and met with Professor Blum to learn more about Lehigh's work on cyber-physical systems. Their research has both commercial and defense applications, and what I learned is essentially all of these cyber-physical systems, or Internet of Things systems, must be built with security as an indispensable component, beginning at the product's start.
The Internet can be used as a weapon of mass destruction, and our electric power grids are a target.
It's so much easier for these guys to cyber attack us than to bomb us, right? I mean, you see what's happening. You know, these other countries, other places are thinking, you know, they're putting together teams to attack us. Why are they doing it? It's so much more inexpensive to do that than to come over and fight us, you know, in a traditional war.
In 2014, Sony Pictures was hacked. The suspects, North Korea. While it served as an embarrassment to the motion picture studio, it wasn't a catastrophic attack.
If we don't put in place the kind of architecture that can prevent these attacks from taking place, this is not just going to be affecting movies. This is going to be affecting our entire economy in ways that are extraordinarily significant.
In 2015, parts of Ukraine's power grid was taken offline by sophisticated attackers. U.S. and Ukrainian officials attributed the actions to Russian actors. The capacity to attack these systems by state actors has clearly been demonstrated. Security can no longer be an afterthought.
I have to actually quote my colleague at Princeton, Vince Poor, who came up with this thing. We should have security by design. Day one, we should be designing the security in. We don't want to come back later and figure out how we make these things secure. Do it in the beginning, security by design.
Part of Blum's research at Lehigh University is developing theories, strategies, even products to secure cyber-physical systems like the power grid. His aim is to understand as much as possible about these networks so anomalies signifying a malicious intrusion can easily be detected.
Some of what we're doing in terms of protecting these systems is basically try to use all the information that we have, right? So we have these physics equations that describe the grid, and then you have these sensor measurements, and then you can try to use all the other information you have. You know, you have all this data, tons of data on, you know, the same situation last year, what kind of generation was there, what kind of demand for energy was there, how was the grid running at that time. So you can take all of this stuff, all weather information, all past information, all this data, and try to use it to try to figure out if what you're seeing is consistent or inconsistent.
Blum showed me a lab here at Lehigh that can basically recreate the conditions within the grid.
You can test it in an environment that looks like it's on a real grid. So all these pieces of hardware here, they essentially simulate the grid.
Blum's work also involves military defense. His Ph.D. student, Jake Perazzone, is working on securing drone command systems.
So drones are controlled remotely, which means we need to send wireless signals to them. So where authentication comes in is when you're sending these wireless signals and the drone's receiving them, it wants to make sure that when it receives them, it's coming from an appropriate source, us, not the bad guy. So authentication allows us to be able to block signals that are coming from a malicious source or an adversary.
If you have many layers of protection, if some of the layers are breached, there's still more layers there to protect you. And there's, you know, certain layers that basically are trying to keep people out of the system. And so the thing that Jake is working on, this authentication, I would view it as one of these layers that's trying to keep people out of the system. So if you were trying to control, for example, a drone, and somebody sends a signal to this drone, the drone's going to check to make sure that this signal's coming from the right person. They're going to perform this authentication. And if this authentication works, then nobody else can control the drone except for the person that's supposed to control it.
The way that we achieve authentication that way is that we slightly perturb the signal in a way that both parties that are communicating with each other would know that it's perturbed in this exact way. So then when you receive this, you check, is it perturbed the way that we agreed that it would be perturbed?
Blum and Perazzone's theories and developments can be used in various sectors, commercial and defense. Authentication and layering appear to be critical to securing industries and vital networks now and in the decades to come.
Our work protects against future advancements in computer technology because with Moore's law, computing power is increasing every single day, every single year. So what our work does is it assumes that the adversary has unlimited computational power. So the best computer that could ever possibly exist, even beyond that. And our work is designing these authentication systems that can even protect against someone who has a computer like that, a supercomputer that can do anything.
In Bethlehem, Pennsylvania, I'm Chloe Nouvelle, PBS 39 News Tonight.